on the periodic table, some things that are very important, and writing symbols, understanding your protons, neutrons, electrons, stuff like that. Now remember, your periodic table is a super cheat sheet. Tells you so many things. Let's start off with number of valence electrons. Okay, valence electrons, VE. The valence electrons, these are the electrons that are on the outermost part of that shell. The valence electrons are the ones that actually do the reacting. This family has one valence electron. This family has two valence electrons. Remember, your transition metals, we don't do them quite the same because they have those d orbitals, which those electrons can move around to benefit them in separate ways or different ways. Okay, your boron family has 3 valence electrons. Your carbon family has 4 valence electrons. Nitrogen family, 5 valence electrons. Oxygen family, 6 valence electrons. The halogens, 7 valence electrons. And then over here, your noble gases or your inert gases have 8 valence electrons, except for helium, which only has 2 valence electrons, because there's only 2 electrons there to do anything with. Doesn't have any more than 2. Now let's see how this affects the charge of the monatomic ion. Okay, so these are your valence electrons. So the charge of the monatomic ion. This is the charge when you don't have to figure out what your multivalent metal charge is. Okay? And remember, monatomic means that, like for example, an example of a monatomic ion would be Cl with a -1 charge. And that gets the IDE suffix. That's monatomic. Okay, so your first family over here is going to have a charge of +1 because it has 1 valence electron to get rid of. Wants to get rid of it very badly. This wants to get rid of 2 electrons, so it's going to have a charge of +2. This one wants to get rid of 3 electrons, so it's going to have a charge of +3. Now, here you can say positive or -4, because you can go either way here. Positive, let me rewrite this, positive or -4. Okay? From here it goes down. You've got 5 valence electrons, so it would be easier for you to steal 3 than to give away 5. So your monatomic anion charge is -3. -2, -1, and these form 0 charge. Now, let's remember one thing that's really important. These 2 families right here, okay, these 2 families right here, and aluminum, zinc, and silver. These have 1 oxidation number or charge. Everything else is multivalent. It can form different charges. Okay? But remember, these are going to form +1. These are going to form +2. Aluminum is always going to form a +3. Zinc, a +2. And silver, a +1. Okay? 3, 2, 1. Now, I use the word monatomic ion charge. But remember, all of these can have multiple valences. All of these can have multiple valences. So when these things act as a cation, you cannot use these charges here. Let me give you an example of what I mean. Let's say that you have N2O5. Okay? So the name for this, the stock name, we have to determine. Okay, so the IUPAC or the stock name, we have to find out the charge before we can name it that way. But the traditional name is pretty easy. Okay, that's dinitrogen pentoxide. Your SLO is not heavy on naming things, so I don't want you to get too bent up on this, but I'm just trying to remind you what I mean by monatomic ion. This, even though nitrogen monatomic ion is a -3, it is not a -3 charge here. Okay, the charge for this is a +5. Okay, the charge on this one right here is +5. So in case you don't remember how to do that, oxygen is the anion, and oxide always has that -2 charge. Okay, so -2. So 5 times -2 gives you a -10 overall. So your overall positive charge has to be a +10. So you have to say 2 times what gives you a +10? +5. 2 times +5 gives you a +10. So if you you would write that nitrogen 5 oxide. Okay, so again, this is not really huge on naming, but I needed you to understand that when the cations, if it is not one of these cations right here, it may not be, you know, these are the only ones that have that fixed cation charge. Okay, they can change. The next thing that I want you to remember is over here, you are forming positive charges. So the left-hand side of your periodic table, we can pretty much draw a little line here. And for the most part, we can, we can say that these form cations, meaning that they become positively charged. And we generally regard these as your metals. Now, if you're touching this line, remember those are your semimetals or metalloids. These over here when they're not forming anions, they can be cations, as you saw in this example right here. Okay? But just to remind you, when you lose electrons, you get a positive charge. When you gain electrons, you get a negative charge. Your positive charge ions are called cations. And if you remember in class, I draw this little cat. See my good drawing skills here? You gotta draw to be a chemistry teacher. And I make his tail positive. That's what I did in class. But now, some chemistry teachers do it this way, and I think what they do is make the mouth like this. Okay, so your cations are positively charged. Yeah, they're just not as good at drawing as I am, so they have to take shortcuts. All right. Another thing from your periodic table that you might want to remember if you want to pass the class is that this number here is your atomic number. Okay, so I'm going to rewrite what is on here. This is nitrogen. And y'all, the ones that we use all the time, like nitrogen, chlorine, fluorine, you should be able to know that chlorine is Cl, fluorine is F, bromine is Br, nitrogen is N, oxygen O, hydrogen H. You should know that we've done those so many times, there shouldn't be any surprises there. Okay, and then they have this number down here, 14.00674. So remember, this is your atomic number, and it tells you the number of protons you have. This is the number that we use as our molar mass. Now I know that at the very beginning of the class we called that AMUs, atomic mass units, but we only do that for like the first chapter, and then we go on to saying that this is your molar mass. Okay, so if you have a question, what is the molar mass of nitrogen? You would just say, and for this you're generally probably going to be fine for rounding, but if you want to go ahead and write it out, that's fine. And we write it grams per mole. Okay, what this does not tell you, this does not tell you your mass number. Remember, this is your average atomic mass. And it takes into consideration all of the isotopes that are, common in nature and their percentages. All right. Now, if you have a neutral atom the number of protons is going to be equal to the number of electrons if your atom's neutral. So now, if we're looking here at our atoms, elements on our periodic table, and let's say we have a neutral atom of phosphorus. You have 15 protons, so you would have how many electrons? 15. Let's say we're dealing with bromine here. You have 35 protons, so if your atom is neutral, you'll have 35 electrons. Take something really crazy, like, I don't know, this 103, this lawrencium that you're never going to do anything with, but it's on here. You have 103 protons. If the atom is neutral, you're going to have 103 electrons. We don't always have neutral atoms, like I talked about up here. So let's just go back and remind ourselves. I want to do, let's do calcium and let's do sulfur. Okay, calcium has 20 protons. And sulfur has 16 protons. Now, calcium, its monatomic ion is going to form a +2 charge. When it is an ion, so this is an atom, it is neutral. So not only does it have 20 protons, but it also has 20 electrons. They balance each other out. It's neutral. But here, this has formed a positive charge. It is a cation that has a +2 charge. So that means that it has lost 2 electrons. So this one does not have 20 electrons. It only has 18 electrons. On the other hand, this forms an anion, or negatively charged particle. Okay, so if you look at where sulfur is, when it is a monatomic anion, it forms a charge of -2. Okay, so sulfur gets a -2 charge. That means that it is, an anion. It has gained 2 electrons. So it no longer has 16 like this. When it is an atom, when it's neutrally charged, it also has 16 electrons. But this no longer has 16 electrons. It's gained 2. So it has 18 electrons. Okay? So the cations lose electrons. Okay? So it's going to make some of you mad, but just remember this. Cats are losers. Loser. So he's not happy because he's a loser. Okay? So your cations are going to lose electrons. Your anions are going to gain electrons. Now, another thing that we can do with this periodic table is electron configuration. So remember that whenever we, do electron configuration, we look at, these are energy levels. 1 energy level, 2 energy levels, 3, 4, 5, 6, 7 energy levels. remember that these right here, and you're responsible, I think, all the way up through 56. You need to be able to do an electron configuration for up to 56. And the good thing about this is that we don't have to, in this class, deal with our f orbitals. So the only thing you really need to remember here is that when it comes to these are your d orbitals. Okay. These are your s orbitals. An s orbital can hold 2 electrons. Okay, so you know, like 1 electron, 2 electron. A d orbital can hold 10 electrons total. 1 electron, 2 electrons, 3 electrons, 4 electrons, 5 electrons, 6 electrons, 7 electrons, 8 electrons, 9 electrons, 10 electrons. Okay? So if you're confused, like, oh, how many electrons can the S hold? How many can the D hold? How many can the P hold? All you got to do is count. Okay? Your S can hold 1, 2 electrons. Your D can hold 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Remember over here, these are your p orbitals. Okay, so it can hold 1, 2, 3, 4, 5, 6 electrons. Okay, so P can hold 6, D can hold 10, S can hold 2. We want to remember, while we're talking about these orbitals, one orbital can hold 2 electrons. Okay, so one orbital can hold 2 electrons. All right, so let's just do an electron configuration. Let's pick something that is over, let's pick your most difficult one that you could possibly have on this exam. Let's do barium. So remember, you can use an arrow diagram or whatever, but it's really easier just to use this periodic table because it's built in to this wonderful, to be used as this wonderful little cheat sheet. Okay, so barium, remember it has 56 electrons, and so all we have to do is on the first energy level, we have the s orbital, so we say 1s, and there can be 2 electrons in the s orbital, but that first energy level, remember, you've got helium over here. The only reason helium is over here is because it is a noble gas or an inert gas. The only reason hydrogen is over here, hydrogen is not a metal, it's a non-metal, and the only reason it's here is because it has 1 valence electron. Okay, so we would say 1s2. We go to our second energy level. We've got 2s2, and then we go over here and we've got 2p6. And then our third energy level, we've got 3s2, and we go over here and we got 3p6. Fourth energy level, now don't let this get you right here because this is where some people are going to choose the wrong answer. Remember, your d orbital is 1 below. Okay, so these are really on the third energy level. These are on the fourth, and these are on the fifth energy level. So we would say 4s2, 3d10, 4p6. Okay, then we come down here to 5, and we get 5s2, 4d10, 5p6, and then down here when we get to barium, it's 6s1, 6s2. When we count all these up, we should get the number 56. So we got 2, 4, 10, 12, 18, 20, 30, 36, 38, 48, 54, 56.